Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. All right, what we're going to do is we're going to continue where we left off with holes and asymptotes. So, same function as before, f of x equals x squared minus x minus 6 divided by x squared minus 9. What we did before was when we put a limit and you got 0 to 0, that means indeterminate. You don't know whether it's 0 or undefined. So you factored your way out of trouble like this, and then you simplified, and then you plugged in 3 again, and you got the actual limit where it was. So here's the picture right here, and so as x approaches 3, the y value that approaches from both sides but never really gets there is 5, 6, which is right before 1, right? So that makes sense. Now what happens if you plug in negative 3 right here? So write this down in your notes like I got, boom, right here. So let's plug in negative 3. Pause the video if you need to, see if you can catch up. So it's negative 3 squared minus negative 3 minus 6 over negative 3 squared minus 9. Cool. Negative 3 squared is 9. Negative 1 times negative 3 is plus 3 minus 6. This is 9 minus 9, which is 0. 9 plus 3 is 12. Minus 6 is 6 over 0. Ooh! That means you have undefined when you have 0 in the denominator. That's undefined. That's not indeterminate. That's undefined. And so what does that mean? Well, let's look at our picture again. Let's look at our little graphy graph, huh? So, as x approaches negative 3, you have a infinite discontinuity right there. So, what did we just learn? So here we go. We have a vertical asymptote, an infinite discontinuity, at a point at which the limit as x approaches c, and c is just some number of f of x is undefined. So when I have an undefined limit, I have a vertical asymptote, infinite discontinuity. Bam, write that in your notes like this. Here's mine. Bam, pause the video if you need to. All right, so now, here's what we're going to do. We'll do a little exercise right here. How about some quick practice? Ooh, there's a cheetah. Her name is Practice. Quick practice, right? Cheetah's quick. That's funny, huh? That's good. Yeah, that's a good joke. So find each of the following limits and determine which is either a whole or a vertical asymptote. So we know that if we have 0 to 0 indeterminate, there's a whole. If we have undefined slope, there's a vertical asymptote. So we're going to do 1, 2, 3 right here. So write these down, pause it, see if you got it. And let's begin, shall we? Here's the first one on the top, f of x. So first one, we're going to find the limit as x approaches 4 of f of x. Try and do this on your own first. Pause the video and see if you can do it. And then unpause it and see if you got the right answer. If not, pause it and fix it. Easy. Okay, so we have 4 squared minus 16 over 4 squared minus 5 times 4 plus 4. Cool. So 4 squared is 16 minus 16, which is 0. And this is 16 minus 20, which is negative 4, plus 4 is 0. What is that? We have a whole at x equals 4. But now we have to get the limit, so I got to factor. Factor the numerator, 0 on the top, negative 16 on the bottom. Factor the denominator, negative 5 on the top, and 4 on the bottom. So this is going to be 4 and negative 4. Add up to 0 and multiply to negative 16. This is going to be negative 4 and negative 1. So my numerator is going to be, so the limit as x approaches 4 of x plus 4, x minus 4 over x minus 4, x minus 1. Cool. So x minus 4 divided by x minus 4 is 1. And so I'm going to plug 4 back in here. So the limit as x approaches 4 of 4 plus 4, and we have 4 here, 4 minus 1. So that's 8 over 3, done. So that's my limit. So there's a whole at x equals 4, and the limit is 8/3. Cool. Next one, same problem. Find the limit as x approaches 1 of f of x. All right, no problem. We're going to plug in 1. 1 squared minus 16 over 1 squared minus 5 times 1 plus 4. So it's 1 minus 16, which is negative 15. 1 minus 5 is negative 4. Plus 4 is 0. Undefined slope. What is that? Oh yeah, vertical asymptote or infinite discontinuity at x equals 1. There we go. So we have a whole at x equals 4 and a vertical asymptote at x equals 1 of this function. Cool. All right, let's try the next one, g of x. G of x, boom. Okay, pause the video, see if you can do this one now. Which one's a whole, which one's a vertical asymptote? Now you've seen me do it. All right, let's try it. So limit as x approaches 5. Let's plug it in. 5 squared plus 10 times 5 plus 25 over 5 squared minus 25. All right. 25 plus 50 is 75 plus another 25. That's a honey or a hondo or 100. 5 squared is 25 minus 25 is 0. Uh-oh. Undefined limits. That means we have a vertical asymptote at x equals 5. Cool. All right, now let's try this one. The limit as x approaches negative 5 of this function g of x. All right, let's plug it in. Negative 5 squared plus 10 times negative 5 plus 25 over negative 5 squared minus 25. All right, this is 25. This is negative 50. So 25 plus negative 50 is negative 25. Plus 25 is 0. And this is 25 minus 25. So you get 0 to 0. Whole at x equals negative 5. Bam. Okay, so now we have to keep going because we have to find our actual limit. We have to answer the question. This limit was undefined. What is this limit? I don't know. All I know is there's a whole at x equals 5. You got to find the limit. So let's factor the numerator. 10 on the top, 25 on the bottom. And the denominator, 0 on the top. Negative 25 on the denominator. So that's going to be what adds to 10 and multiplies to 25. That would be 5 and 5. And this is what adds to 0 and multiplies to negative 25. 5 and negative 5. Cool. So we have the limit as x approaches negative 5 of, here's my numerator, x plus 5 times x plus 5 divided by x plus 5, x minus 5. Bam. So this is going to be, that equals 1. Now I'm going to plug in negative 5. Negative 5 plus 5 over negative 5 minus 5. So that's 0 over negative 10. Which is 0. Boom. So that's the limit. Limit as x approaches negative 5 of this function, g of x, is 0. Cool. All right, last but not least, you know there's a challenge and one at the end. You know, h of x. Last one. See if you can do it. Challenge yourself, pause the video, knock it out. Bam. All right, let's try it. So limit is x approaches 0 of h of x. So 0 squared minus 3 times 0 over 0 squared minus 9 times 0. So 0 to the third, my bad. This is the third power. Okay, so that's 0 minus 0, which is 0. 0 minus 0, which is also 0. Indeterminate, hello. So we have a hole in the graph at x equals 0. All right, let's factor our way out of trouble, shall we? So factoring sort of takes a different turn on here because you can't draw an x here because there's no c value. When there's no c value, no constant, you can't do that. But I just look and see what they have in common. So what do these two terms have in common? Yeah, x. So the limit as x approaches 0, I'm going to take an x out of this. So it's x times x minus 3. Boom. Now, here, in the denominator, what do they have in common? Yeah, an x. So that's x squared minus 9. Bam. So I can simplify this if I want. X divided by x is 1. So I can get that out of the way. Now I can plug in 0. Let's see what I get. Let's plug in 0. So it's going to be 0 minus 3. And this is going to be 0 squared minus 9. So that's going to be negative 3 divided by negative 9, which is simplifies to, oh yeah, 1/3. So there's a hole at x equals 0, and the limit from both sides, you're approaching the y value of 1/3. Cool. All right, last but not least, let's see how we doing. All right, so limit as x approaches 3. So let's plug it in. 3 squared minus 3 times 3 over 3 to the third minus 9 times 3. So that's 9 minus 9, which is, 0. 27, 3 times 3 times 3 is 27 minus 27, which is also 0. Uh-oh. So we got another whole at x equals 3. Cool. Let's factor our way out of trouble. So we already factored this thing, so we already got it here. So we factored it, so we already did that. So the limit as x approaches 3, so I'm going to write this down again. So it's x, took an x out of the numerator, and I took an x out of the denominator. Bam. So we had x divided by x is 1, because whenever the same numerator and denominator equals 1. So then I'm going to plug in 3 again, just like I plugged in 0 here. So that's going to be 3 minus 3 over 3 squared minus 9, which is, damn, 0 to 0 again. So I got indeterminate not once, but twice. So what do you think I'm going to do? Oh yeah, I'm going to keep going. I'm going to keep factoring, because look, I can factor this denominator. Hello. So the limit as x approaches 3, I have x minus 3. I can't factor that, but I can factor this denominator here, can't I? So 0 on the top and negative 9 on the bottom. What adds to 0 and multiplies to negative 9? 3 and negative 3. Cool. So my denominator is x minus 3, x plus 3. Doesn't matter what order you put in, because when you multiply this, you get the same answer. So x minus 3 divided by x minus 3 is 1. That's why we say 1, because you don't say cancel, because that equals 1. So x plus 3 is not on the numerator. That's not the answer. It's 1 over x plus 3. So the limit as x approaches 3 is 1 over x plus 3. Because this remains on the denominator, because this equals 1, and that 1 remains there on the numerator. So now I'm going to plug in 3 and finish it. 1 over 3 plus 3, which is 1/6. Got it. So there's a whole at x equals 3, and the limit is 1/6. Cool. Nice job, everybody.